You try some on your own. Example number 1. Just watch and learn as I solve this equation with variables on both sides. So when you have variables on both sides, the goal is to get the variables on one side and the constants on the other. So since there are variables on both sides and constants on both sides, it's your choice. Do you want the variables on the left or do you want the variables on the right? It doesn't matter, there's no wrong answer. It's just your personal preference. I'm going to put my variables on the left for 2 reasons. 1, it's familiar to me and I'm comfortable with variables on the left. And second, if I take my 3y here and subtract it, then 5y minus 3y will remain positive. So those are the 2 reasons that I'm going to elect to keep my variables on the left-hand side. Keeps my variable positive, and I prefer them over here on the left. I rewrite everything in the problem that I haven't used, and then I move on to my second step, which is actually another repeat of the subtraction property of equality. In this case, I have a constant that's minus 8, so I'm going to use the addition property of equality on both sides, giving me a cross out and a rewrite of 2y is equal to 20. Use my multiplicative inverse here, divide both sides by 2, and I get my final answer, which is 10. Y is equal to 10. So you notice I used my addition property of equality twice before I moved on to my division property of equality. Let's take a look at another question. On this second example, we have, again, a variable and a constant on the left, and a variable term and a constant on the right. So there are 4 starting points for this problem. I can add 6x to both sides, I could subtract 14 from both sides, I could subtract 12 from both sides, or I could add 8x to both sides. I'm going to choose to add 8x to both sides because this is the smaller value, and by adding 8x to both sides, my variable term stays positive. 2x, rewrite the rest of my question, plus 14 is equal to 12. Now use that property of equality again to move my constants together, and I get 2x is equal to negative 2. Multiplicative inverse, final answer. Let's take a look at one last question. Now in this question, you'll notice that my left-hand side only has one term. It's a variable term. My right-hand side has 2 terms, a variable term and a constant term. Now I could certainly add 36 to both sides. That would be mathematically sound, but it's not very productive because I can't combine a 36 with a 7k. So that just makes my left side longer and my right side shorter, but it doesn't make the problem any simpler. So I'm going to choose to subtract 3k from both sides. Now I don't want to subtract 7k because if I did that, my entire left side would be empty. Now it's not wrong, you could certainly do that, but it's not very helpful. So let's try this by subtracting 3k from both sides and keeping my equation balanced with a term on the left and a term on the right. Okay, if you need to go back and watch these 3 examples again, please do that. Otherwise, make sure you copy the original question into your notebooks and solve each question here. Pause the video now until you're ready to check your solutions. Okay, now that you've had a chance to work the problems out on your own, let's take a look at the 2 solutions for examples 1 and 2. Now your work does not have to look exactly like mine. Remember, if there are 4 terms, there are 4 ways to solve this problem. The only one I want you to be careful of is question number 2. Don't make this common mistake that I see a lot of students do, which is that they subtract the smaller variable term, and then as they're rewriting the problem, they magically take this plus 40, which is on the left side of the equal sign, and they magically place it over here on the right. That's a very common mistake. Don't make that mistake. If you were going to subtract 2 from both sides, technically, this is what the problem would look like. If you had subtracted 2a properly, then the left side would contain 2 terms, the new variable term and the old constant term. Now this isn't wrong, it just makes the problem longer, because now I have to move this constant term over to the other side. So what I could have solved in 1 step, I now have to do in 2 steps. It's not wrong, it's just longer. But you'll still get the same solution. All right, let's take a look at 2 more questions. In this question, we're going to introduce another property, which would be the distribution property, right? The distributive property of multiplication, in this case, over subtraction, because there's a subtraction sign in the problem. So we have negative 1/2 times 12v, which is negative 6v, and a negative 1/2 times 20, which is positive 10. The rest of the problem remains the same. As soon as you hit the closed parens, you stop distributing. Now in this question, after I finish my first property here, I have 3 terms on the left-hand side. That's too many. The most you should have is 2, a variable term and a constant term. If you have 3 terms, that means some terms can be combined. In this case, it's these 2 because they're both constants. So if I shrink this problem down, I'm going to keep my negative 6v, but my 10 plus 4 will turn into a 14. Everybody else remains the same, and now I can choose a starting point. I'm going to choose to start with this 8v because it's a smaller value. I'm going to add 8v to both sides. Gives me 2v plus 14 equals negative 12. And then I'm going to subtract 14 from both sides. And I'm going to get 2v is equal to negative 26. Divide both sides by my coefficient and get my final answer. All right, we're going to look at one last question, and then you're going to try the final 2 examples on your own. Last question has the distributive property on both sides of the problem. So on the left, I'm going to get a 7p plus 21, and I stop distributing and just copy the rest. On my right, I'm going to get 5p minus 10. I'm going to stop distributing because I hit the end of the parentheses, and I'm just going to copy the rest. Now in this case, my left side has 3 terms, so my constant terms can be combined. My right side also has 3 terms, and my variable terms are going to be combined. So that leaves me with a 7p plus 30 and a 2p minus 10. Alright, I'm going to choose to move my variables left, so I'm going to subtract 2p from both sides. And I'm going to do some shorter work here, and I'm going to choose to, at the same time, use another property of equality, which is that I'm going to subtract my constant term, or add my constant term. Now look, I already have a cross out on the right, so I cannot have 2 cross outs on the same side. That would be unfair. So that means I cannot do the opposite of anybody over here. I have to choose one of these. Well, he's already taken because he has a combination problem he needs to finish. So I'm going to subtract 30 from both sides. And that gives me a cross out on both sides, which is fair. And now I can rewrite my problem. 5p is equal to negative 40. Divide both sides by my coefficient and get my final answer. Alright, you're ready to try these last 2 questions in your notebook on your own. Copy the question, show your work, and then after you're finished, unpause the video to check your solutions. Pause the video now. Okay, now that you've had a chance to try these last 2 on your own, let's check your work. So for question number 3, the answer was negative 2. And for question number 4, the answer was -1. That concludes our video on how to solve algebraic equations with variables on both sides.